begin a brief refresher about how to use fractions, starting out with equivalent fractions. Um, Getting equivalent fractions is important in many of the things that you'll be doing, especially when we get to adding and subtracting fractions. So let's start with something easy. Our first example, let's just look at 1 over 2, 1 half. When we're talking about equivalent fractions, what we're talking about is your ability to multiply the same number on the top and bottom. Let's look at times 2 times 2 to keep a fraction equivalent. 1 times 2 is 2, 2 times 2 is 4. Therefore, 2/4 is an equivalent fraction to 1 over 2. You could also make this into a much larger number. You could do 1 half times 20 on the top and bottom to make that 20 over 40. Essentially, what you do is find the number on bottom that you want to turn this fraction into when you add and subtract. So 20 is half of 42 is half of 4, and any multiple that you would make, top and bottom it's the same, but keep that as an equivalent fraction. Now when it wouldn't be as obvious, let's look at 3/8. If I wanted to turn my 8 into 16ths, what I would do is multiply by 2 on the top and on the bottom. Therefore, 3 over 8 would be the same as 6 over 16. Now if you want to turn that 8 into 30 seconds, that would be 3 over 8. And if you're trying to get to 30 seconds, you're going to multiply by 4. And if you do that on the bottom, you'll also do that to the top. So 3/8 would equal 12 over 32. Now let's look at our next topic, which would be adding and subtracting fractions. So we'll just get right into that. One thing you need to be sure that you understand is you do need a common denominator when you add and subtract fractions. Let's look at a first example. Let's take 3/8 and we'll add 2/8 to it. Now in this case, you already have the same number on the bottom. You have 3/8 and you have 2/8. Therefore, all you have to do is keep the bottom number the same. Be sure you don't add them together. That is something that is a common mistake. And 3 plus 2, you just perform the operations on top. So this works for both positive integers and negative integers. But 3 plus 2 is 5. This cannot be simplified, so 5 over 8 would be your answer. Now let's look at one that would not be common on the bottom. 1/8 plus 3 over 4. Now this one's still not too bad. You want to take a quick look at whatever problem you're working on when you add and subtract to see if one can turn into the other through multiplication. So what I mean by that is, can 4 be turned into 8 by multiplying by a whole number? And in this case, it can. What you want to do is multiply the top and bottom of the number by the same. 4 times 2 will give you 8. So when you rewrite that problem with common denominators, you have 1/8 plus, now 3 times 2 is 6, 4 times 2 is 8, and at that point, it's the same as the problem over here. You keep your bottom number 8, and your top number 1 plus 6 is 7, and that cannot be simplified, so you're at your final answer. Alright, let's look at an example to where it's not quite so simple. Let's look at 9 over 12 plus 12 over 16. Now in this case, when you look at the two bottom numbers, which is the first place you want to look at all of addition and subtraction problems, the 12 and the 16 cannot turn into each other. So what you're going to have to do is find a number that both of these will go into. At some point, if all else fails, you can always multiply them together, but you end up with a very large number typically, and it's usually easier to find a multiple of the larger one. So you go with the 16 and stop when you find a multiple of 12. So 16 times 1, which that's not going to help you, will be 16. 16 times 2 would give you 32, but 32 isn't a multiple of 12. 16 times 3, that is 48. So that is a multiple of 12. So that'll be the easiest number to use as your common denominator. I can turn 12 and 16 into 48. Now let's rewrite the problem using my 48 as my denominator. Once I've done that, what I want to determine is what 9/12ths turns into when it converts into a fraction with 48 on the bottom. And I need to find my multiple to go from 12 to 48. In this case, that multiple is 4. So times 4 times 4 on top and bottom. And then 4 times 9 is 36. So in place of 9/12ths, we will put 36 over 48. So now let's focus over here. Now we've already done the multiple over here. 16 times 3 gives me 48, so I'm going to perform that operation right here. And it turns out 12 times 3 is also 36 over 48. So it's a fairly painless process. Keep your bottom number the same when you have common denominators. Don't add those together. 36 plus 36 gives you 72. There's more than one way to handle this. Going more toward algebra, mixed numbers are not that necessary to use in algebra. But one thing that you don't want to do is leave one that's not simplified. Now 72 and 48 are both even numbers, so 2 could be factored out of both of them. But I think we can get bigger than 2. Looking at them, one of the most obvious things that will come out would be either 4 or 6. And some of you may recognize that you could do both at the same time and save a step here, but 72 divided by 6 is 12, and 48 divided by 6 is 8. And at this point, you can actually reduce that again by a factor of 4, so that fraction in simplest form would be 3 over 2. Now, I could have saved a step right there, but not as many students would catch that typically. 72 over 48 are both of those are multiples of 24. And usually you'll get better at identifying those as you gain more practice. There are 3 24s in 72. There are 2 24s in 48. So either way I arrive at that same answer, so do what you're most comfortable with. This wouldn't be acceptable as a final answer. Don't worry about making this into 1.5 or into 1.5 at this stage. That is not important. Preparing for algebra, the improper fraction 3 over 2 will be just fine. Alright, let's move on to the next operation, multiplying fractions. Now, the most common thing I see people create headaches for themselves with on multiplying fractions is creating a common denominator. Do not use common denominators when you multiply. You will end up, if you're lucky, with the same answer, but it'll be much harder to come by. So let's look at a fairly simple multiplication problem involving fractions. 1/4 times 3 over 8. Now, the most straightforward way of multiplying fractions is just to multiply across the top. 1 times 3, and you get 3. And then multiply across the bottom. 4 times 8, and you get 32. Now 3 over 32 can't be simplified, so that works out just fine for this example. Let's look at another example to where there's more than one way of doing that. Let's look at 3 over 16 multiplied by 8 over 9. Now, for students who aren't as strong in multiplication and division as others, it may be easier to learn a simple technique called cross-simplifying. I'll show you in a second. But repeating the process we used up here in this example, 3 times 8 is 24. And then 16 times 9, which is not as obvious, would give you 144. Now both of these are even, so I know it can reduce. So I know it'll divide by 2. Since they're even, it will divide by 2. So let's just try that. 24 divided by 2 is 12. 144 divided by 2 is 72. Now they're both even again, so I'm going to multiply by 2 again. 12 divided by 2 is 6. 72 divided by 2 gives me 36. Now at this point, I recognize that both of these are divisible by 6. And different people are at different comfort levels here. So you may realize that both of these could be divided much further than what we showed here. But it'd be 1 over 6. So that'd be one approach. Now, I like to try to avoid all of this if at all possible. So let's revisit the problem in its very first stage. 3 over 16 times 8 over 9. Now, if you're familiar with cross-simplifying, it means you can multiply across diagonally or up and down. But you can simplify before you do all the multiplication and have these larger numbers. What you recognize is that in this set of diagonals, 8 and 16 are both factors of 8, are both multiples of 8, excuse me. So 8 will go into 8 one time, and 8 will go into 16 two times. Now looking at this set of diagonals, 3 and 9, they're both multiples of 3 also. 3 goes into 3 once, 3 goes into 9 3 times. Once you've done that simplification process, then you multiply across the top as we did up here in this example. 1 times 1, obviously we'll have 1 as a numerator. And the denominator will have 2 times 3, which is 6. You note that that's the same result that we achieved in this version, which is much simpler mathematics to do. So as you get more familiarity with how these work and you get refreshed on those, cross-simplifying is a much easier version to get those done efficiently. And lastly, let's look at dividing fractions. Again, do not use a common denominator when you're doing division of fractions. The most important thing to realize is that you never actually divide. So let's look at a problem 6 divided by 3 over 2. Now you'll end up multiplying, and some of you may be familiar with leave, change, flip. What that means is you leave the first one alone, you change division to multiplication, and you flip over whatever fraction follows that division sign. Also, with some students, and this is purely dependent on where you are, ability-wise and comfort-wise, we'll change a whole number into a fraction. So if you would like to do that, that's fine. Change your division sign into a multiplication sign, and then take the reciprocal, 3 over 2, which is 2 over 3. Just switch the numerator and denominator. Now once here, you have your choices of solutions. You can do 6 times 2, which is 12, 1 times 3, which is 3, and then recognize this as a division problem with a whole number output of 4. Or you could have seen that 6 and 3 have 3 as a common factor, where you would have done 2 times 2 and skipped the 12 over 3 step to get 4. Notice since 1 was the only number left in the denominator, I didn't write a separate step as 4 over 1 and input equals 4. But be sure to never leave your final answer as 4 over 1. You need to go ahead and solve that for it to be in simplest form.